Hello everyone, welcome back to the channel. Today, we are diving into something super important for anyone studying computer science, electronics, or even just curious about how numbers work in computers. We are talking about number system conversions, specifically converting between decimal, binary, and even fractions. So, if you have ever wondered how computers handle numbers, this video is for you. Let's get started. First, let's talk about decimal to binary conversion. This is one of the most common conversions you will encounter. The decimal system is what we use every day. It's base 10. But computers, they think in binary, which is base 2. So, how do we convert a decimal number to binary? Well, it's actually pretty straightforward. Let me break it down for you. Here's the step-by-step process. 1. Divide the decimal number by 2. 2. Write down the remainder. It will always be either 0 or 1. 3. Take the quotient from the division and divide it by 2 again. 4. Repeat this process, recording the remainder each time until the quotient becomes 0. 5. Finally, the binary number is the sequence of remainders read from the last remainder to the first, that's bottom to top. Let's take an example to make this clear. Say we want to convert the decimal number 125 into binary. Here's how it works. 125 divided by 2 gives 62 with a remainder of 1. 62 divided by 2 gives 31 with a remainder of 0. 31 divided by 2 gives 15 with a remainder of 1. 15 divided by 2 gives 7 with a remainder of 1. 7 divided by 2 gives 3 with a remainder of 1. 3 divided by 2 gives 1 with a remainder of 1. Finally, 1 divided by 2 gives 0 with a remainder of 1. Now, if we read the remainders from bottom to top, we get 1111101. So, 125 in decimal is 1111101 in binary. Pretty cool, right? Now, what if we have a decimal number with a fractional part? For example, 105.15. How do we convert that to binary? Well, it's a bit different, but don't worry, I will walk you through it. First, let's handle the integer part, which is 105. We'll use the same method we just discussed for converting decimal to binary. Let's break it down. 105 divided by 2 gives 52 with a remainder of 1. 52 divided by 2 gives 26 with a remainder of 0. 26 divided by 2 gives 13 with a remainder of 0. 13 divided by 2 gives 6 with a remainder of 1. 6 divided by 2 gives 3 with a remainder of 0. 3 divided by 2 gives 1 with a remainder of 1. Finally, 1 divided by 2 gives 0 with a remainder of 1. Now, if we read the remainders from bottom to top, we get 1101001. So, the integer part 105 in decimal is 1101001 in binary. But for the fractional part, 0.15, we do something different. Here's how it works. 1. Multiply the decimal fraction by 2. 2. Record the integer part of the result. It will be either 0 or 1. 3. Take the fractional part of the result and multiply it by 2 again. 4. Repeat this process until the fractional part becomes 0 or until the digits start repeating. Let's apply this to 0.15. 0.15 multiplied by 2 is 0.30. The integer part is 0. 0.30 multiplied by 2 is 0.60. The integer part is 0. 0.60 multiplied by 2 is 1.20. The integer part is 1. 0.20 multiplied by 2 is 0.40. The integer part is 0. 0.40 multiplied by 2 is 0.80. The integer part is 0. 0.80 multiplied by 2 is 1.60. The integer part is 1. So, the binary fraction is 0.0011. 1001. When we combine this with the integer part, which is 1101001, the final binary equivalent of 105.15 is 1101001.001001. Now, let's flip it around. What if you have a binary number and you want to convert it back to decimal? Don't worry, it's just as easy. Let me show you how. Here's the process. 1. Write down the binary number and assign each digit a position value, starting from the right. 2. Multiply each binary digit by 2 raised to the power of its position value. 3. Add up all the results from the previous step to get the decimal equivalent. Let's take the binary number 100011. Here's how we convert it to decimal. Starting from the right, the positions are 0, 1, 2, 3, 4, and 5. So, 1 is at position 0. Therefore, it is 1 times 2 to the power 0 equals to 1. 1 is at position 1. Therefore, it is 1 times 2 to the power 1 equals to 2. 0 is at position 2. Therefore, it is 0 times 2 to the power 2 equals to 0. 0 is at position 3. Therefore, it is 0 times 2 to the power 3 equals to 0. 0 is at position 4. Therefore, it is 0 times 2 to the power 4 equals to 0. 1 is at position 5. Therefore, it is 1 times 2 to the power 5 equals to 32. Now, add them all up. 1 plus 2 plus 0 plus 0 plus 0 plus 32 equal 35. So, 100011 in binary is 35 in decimal. Now, let's take another example, this time with a binary fraction. Let's convert 110.01 to decimal. Here's how it works. For the integer part, 1101, 1 is at position 0. Therefore, we get 1 times 2 to the power 0 equals to 1. 0 is at position 1. Therefore, we get 0 times 2 to the power 1 equals to 0. 1 is at position 2. Therefore, we get 1 times 2 to the power 2 equals to 4. 1 is at position 3. Therefore, we get 1 times 2 to the power 3 equals to 8. Add them up and we get 1 plus 0 plus 4 plus 8 equal 13. For the fractional part, 0.01, 0 is at position minus 1. Therefore, we get 0 times 2 to the power minus 1 equals to 0. 1 is at position minus 2. Therefore, we get 1 times 2 to the power minus 2 equals to 0.25. Add them up, we get 0 plus 0.25 equals to 0.25. So, the decimal equivalent of 110.01 is 13.25. And that's it. Whether you're converting from decimal to binary or binary to decimal, it's all about following these simple steps. If you practice a few times, you'll get the hang of it in no time. Thanks for watching, everyone. If you found this video helpful, don't forget to give it a thumbs up and share it with anyone who might need it. And if you have any questions or want to see more content like this, drop a comment below. Until next time, happy learning.